Hello everyone, I'm Lakshmi Singh. Welcome to All This Math channel. Today's discussion topic is sample space and events. So first, what is experiment? Before starting sample space, first you have some knowledge regarding experiment. So an experiment is the set of observation in a chemistry laboratory or a set of measurements in a physics laboratory or a set of values corresponding to a process. You know, chemistry in chemistry laboratory, you all do something like observations, and in physics laboratory, you have done some measurements also. Like this, that is called experiment, and all experiments have some outputs. In this probability, we call these outputs as outcomes, and we write all outcomes in one set that is called sample space. So here it's written the possible values of an experiment are otherwise termed as the outcomes of an experiment. That means all outputs we may call these are outcomes. And so comes to our definition of sample space. So sample space is denoted by capital S, and it is defined as total possible outcomes of an experiment. If we write all outcomes in one set, is known as sample space. Suppose we toss a coin. One time we toss a coin. So what is its outcome? It has some outcomes like head or tail. If you find head, suppose you write head as H and tail as T. If you write in one set, this is called sample space. So sample space looks like this. That is in one set, head and tail together here, and the sample space is denoted by S. So here is one example. Find out sample space corresponding to the tossing of coins. Here it's not given how many times we toss a coin. Suppose either it's 2 times, 3 times, 4 times, like this. So if we toss a coins individually, how you will able to answer at 1 second? What is its answer? Like this. So here this answer is here. So we shall consider the tossing of coins individually. If one coin tossed once, then S equals to either head or tail comes. So we may write in one bracket, that is H and T. And if we take a sample space cardinality, then it is, if we count it, this is 1 and 2, so it's 2. And here it's written H stands for head and T stands for tail. So similarly, if one coin tossed twice, then or two coin tossed once, then S equals to either it is HH, HT, TH or T2. So how you will able to find this? So if we toss a coin, so either it is suppose either H or T comes. So again, if we toss a coin, so H having two options, either H or T. Similarly, tail having two options, either H and T. So if you combiningly write, so we may write HH, HT, TH, comma TT. So like this, I have 4 outcomes. If I write all outcomes in one set, this is called sample space. Then sample space cardinality, if we count it, this is 4. 4 means 2 square. Similarly, comes to another point, if one coin tossed thrice or 3 coins tossed once, then what will be your S? So I'll take again H having Look at this tree, HT, T having, if we toss another time, T having HT. Similarly, H having outcomes, HT. And T having outcomes, H and T. So if you combiningly write, how you will write? H, 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 T, then H, H, T, H, H, T, 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 H, H, then T, H, T, then T, T, H, then T, T, T. So all outcomes combiningly we write in one set. This is called sample space. If we count it, then it will be S cardinality is 8, that is 2 to the power 3. So similarly, if you want to find 4 times, if we toss a coin, then S will be like this by using that previous tree diagram. Then if you count it, it will be 16, that is 2 to the power 4. So what you conclude from here, from that question, so if we toss a coin once, then sample space cardinality is 2. That is 2 to the power 1. If we toss a coin 2 times, then sample space cardinality is 2 to the power 2. If we toss a coin thrice, then sample space cardinality is 2 to the power 3. Similarly, if we toss a coin 4 times, then it is 2 to the power 4. So if you want to write nth time, if you want to write if point toss 120 times, so what will be its sample space cardinality? So it's simply by using this formula. Similarly, if one coin tossed for n times or n coin tossed once, its formula is sample space cardinality is 2 to the power n. So if we toss a coin 120 times, then what will be the answer? Sample space cardinality equal to 2 to the power 120. So comes to another example, that is find out the sample space corresponding to rolling of a die or dice. If we roll a die, that is 1 time, that is die, that is 2 times, 3 times, that is called dice. So if we roll a die, then what is its outcome? It outcomes maybe 1, maybe 2, maybe 3, maybe 4, maybe 5, maybe 6. You don't know what is its outcome. So but you would know maybe 1, maybe 2, maybe 3 comes out, maybe 4 comes out, maybe 5 comes out, maybe 6 comes out. So all outcomes or all possible outcomes, if you write in one set, this is called sample space. So if we count it, then sample space cardinality equal to 6. Similarly, if a die rolled twice or 2 dice rolled once, then what will be the sample space? So how you will write this? So 1 with 1, then 1 with 2, 1 with 3, 1 with 4, maybe 1 with 5, maybe 1 with 6. Similarly, 2, 1, 2, 2, then 2, 3, then 2, 4, then 2, 5, then 2, 6. Up to like this 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, up to 6, 6. If you count it, then sample space cardinality is here 36. How? 1, 2, 3, 4, 5, 6. So 6 times, so 6 into 6 is 36. 36 means 6 square. Similarly, if a die rolled thrice or 3 dice rolled once, then it is not possible to write all elements here, but it will be like this, that is 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 1, 4. Like this, if you want to write like this, you will write that portion 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 1, 4, up to 1, 1, 6. Then 211, 221, 212, 213. Like this, you will write all elements, but the last element, at most element is 666. So if you count, then you will get sample space cardinality is 6 to the power 3, that is 216. So similarly, if one die rolled for n times or n die is rolled once, then sample space cardinality will be 6 to the power n. So here another question comes to our mind. If if one die rolled 900 times, then what will be its sample space cardinality? Then simply you tell sample space cardinality is 6 to the power 900. So like this, you'll able to write all answers at 1 second. Similarly, check this example 4.7 comes to this example. This is one card problem. So here it's a question given, find out the sample space corresponding to the randomly drawing of cards from a pack of well shuffled cards. Since so we don't know how many number of cards here, and we don't know how many times we draw that cards, but here I'll give every answer and you all are able to give any type of questions answer. So since we know that a pack of well shuffled cards contain 52 number of cards, total number of cards in a pack, that is 52. And remember another thing also, number of red cards equal to number of black cards, that is 26. Number of black cards is 26 and also number of red cards is 26. And in one pack of card, there are 4 suits. What is that suit? And each suit contains 13 number of cards. And what is that suit? That is clubs, spades, hearts, and diamonds. Where these first 2 clubs and spades are called black cards. These are black cards, and hearts and diamonds are red cards. And each suit, that is each suit means clubs, spades, hearts, diamond. Each suits contain 13 number of cards. So if you may face that type of question, that is here it's written, we know that a pack of well shuffled cards contains 52 number of cards. Hence, we consider drawing of cards in step-by-step manner. If a single card is drawn from a pack of cards, then sample space cardinality will be 52C1. What is C? C stands for combination. And what is the formula for combination? If NCR is there, then what is its formula? N factorial divided by R factorial into N minus R factorial. By using that formula, you will able to solve 52C1. But directly, if below C1 is there, directly you will write its answer is N, that is 52. That is by using this formula. Similarly, if a single card is drawn from a set of red cards or set of black cards, then sample space cardinality will be 26C1. Similarly, if a single card is drawn from a suit, then sample space cardinality will be 13C1 because a suit contains 13 cards. Then it's 13C1. That means from 13 cards, you have to draw 1 card. So it will be 13C1. Similarly, if 2 cards are drawn from a pack of cards, then what is its answer? Sample space cardinality is 52C2. 52C2. Okay. Then similarly here another question given, if 3 cards are drawn from set of red cards, then S value is 26 C3, because here it's given 3 cards are drawn from a set of red cards and you know red cards contains 26 number of cards. Similarly, if n cards are drawn from a set of suit, then what is its answer? Sample space cardinality is 13 Cn. But remember that thing, n must be less than or equal to 13. Why? In combination, there is one other formula, NCR. That means here one condition is there, always R less than equal to n. Remember that formula. That is one condition in combination. Then this is one another question. If you want to solve, you solve by yourself this question. Then comes to another question, example 4.9, that is find out the number of elements of the sample space corresponding to the different arrangements of vowels of English alphabet. So how you will able to solve this type of problem? Since we know that there are 5 vowels, such as these names are A, E, I, O, U, and this can be arranged having having following categories. That is, if we take sample space containing one vowel, so what is its arrangements? Either A comes out, either E comes out, either I comes out, either O comes out, or U comes out. If we write in one set, then this is sample space. Since I'll solve another sample space, so I'll write this sample space as S1. And if you count it, S1 cardinality is 5. Similarly, S2, that is sample space containing 2 vowels arrangements. So if you want to write all vowels together, like your die problem, like this. So write in this way, A, then AE, AI, AO, AU. Similarly, EA, EE, EI, EO, up to U point. And if you count it, you may find there are 25 number of elements. Similarly, S3 cardinality is 125, S4 cardinality is 625, S5 cardinality is 3125. So if you write all together, then this is your total number of arrangements, that is S1 cardinality plus S2 cardinality plus S3 cardinality plus S4 cardinality plus S5 cardinality. So if when you add it, you'll get your answer, that is 3905. Then comes to our another point, because before starting probability, that's very important to know what is sample space and what is event. So then comes to our event point. What is event? So event means any subset of the sample space is known as event. So what do you mean by sample space? Suppose A is one set. Suppose A is one set, that is 1, 2, 3, 4. 1, 2, 3, then 4. Then B is another set. Suppose 2, 4. 2, 4. Okay. Then we may call B is subset of A. B, this is subset symbol. B is subset of A. This symbol is for subset. Okay. So any subset of the sample space is known as event. So any subset of the sample space. So here in S2, so many outcomes are there. If I'll write in another set, that means S1. S1 element is A, E, I, O, U, but all things not in S2. So that means S1 is not a subset of S2. But if I'm right in another set AE, and AI, that is, and this set, suppose I'll write the notation. This set is S9. So S9 is the subset of S2 because S9 contains AE, and AI. So S9 is the subset of S2. So any subset of the sample space is known as event. So check that example. This is one simple example. So here question given, find out the set of events corresponding to the even numbers, odd numbers and prime numbers. Some appeared in rolling of 3 dice once. Since we know even number, suppose I'll write E stands for event that the sum appeared is even in rolling of 3 dice once. O stands for event that sum appeared is odd in rolling of 3 dice once. Similarly, P is the event that sum appeared is prime in rolling of 3 dice once. So I want to write all events elements. So what is, so now comes to here, what is your sample space? So since here question given, find out the set of events corresponding to even numbers, odd numbers and prime numbers. Sum appeared in rolling of 3 dice once. Sum appeared in 3 dice once. Sum, SUM, sum means that is the addition. So if 3 dice rolled once, so what is its minimum element? So check here, here minimum element 1, 1, 1. If you add it, then it is 3. Then 1, 1, 2, it is 4. Then at most point is 6, 6, 6. If you add it, that is 18. So here sample space may be 3, 4, 5 up to 18. Then comes to our question. You have to find out set of even number element, set of odd number element, and set of prime number element. Then here, what is even number? You know, from 3, it's the natural number starts. So we may write its even number is 4, 6, 8, 10, 12, 14, 16, and 18. And the number of odd numbers, that is 3, 5, 7, 9, 11, 13, 15, then 17. Then prime number means if a number is divisible by 1 and itself, that is called prime number. So here prime number elements may be 3, maybe 5, maybe 7, maybe 11, maybe 13, maybe 17. It is 13 and 17. It's compulsory. So if you count it, event cardinality is here 8. E cardinality, that is even number cardinality is 8, odd number cardinality is 8, and prime number cardinality is 6. And check here, these all elements lies in sample space. If we write this is sample space, so all elements are in sample space. So E is subset of S, O is subset of S, P is subset of S. So for that case, E, O and P are called events. So similarly, another important question is here. Question given, out of 20 balls in a basket, 7 are too small, 8 are too big, and 5 are of normal size. If a person draw 3 balls at random, then find out the sample space and the event containing 2 different size balls. So here I'll take, let A stands for, S denotes 2 small size ball, B denotes 2 big size ball, and N denotes normal size balls respectively. So given that here question given, Look at this question. So here it's given out of 20 balls in a basket. That means a basket contains 20 balls. From these, 7 are too small, 8 are too big, and 5 are of normal size. If a person draw 3 balls at random, then find out the sample space and the event containing two different size balls. That means first you have to find sample space, then after that you will evaluate event containing two different sizes of balls. So sample space, so what will be its answer? 20, total number of ball is 20. From this you will draw 3 balls, so this is in 23. That is n factorial by r factorial into n minus r factorial formula, that is 20 factorial by this thing. Then how you will you know how to solve also factorial values. So in this way you solve this and you will get this answer is 114. Similarly, let E is the event that the 3 balls were drawn containing two different size balls. If you want to solve manually, so how you will able to solve? So you will write two different size, that is SSB, that is SS is too small ball and B is big ball. So it may be possible. Similarly, SVS, it may be possible. BSS, it is also possible. So you write all these elements manually, and if you count it, then E cardinality is 18, and all balls lies in sample space. So E here subset of S. Then E is called event. So here comes to our definition of mutually exclusive event. What do you mean by mutually exclusive event? Suppose two persons are, suppose one person is Ram, another person is, suppose girl name is Jaya. And Ram is a boy and Jaya is a girl. If I'll take gender wise intersection, then Ram intersection Jaya is 5. That is no common gender there. So in this way, if two events are said to be mutually exclusive, then if they are disjoint means no common elements between that two events, then A and B are said to be mutually exclusive. That means A intersection B equals to 5. This symbol is 5. So two events are said to be mutually exclusive if they are disjoint. That is A and B are said to be mutually exclusive if A intersection B is 5. So here one question given like mutually exclusive. This type of question comes in MCQ type. Express, but here another question. Express sum of numbers appeared in rolling of two dice once as two mutually exclusive events. Since here also question given sum of numbers appeared in rolling of two dice once, so we know that the sum of numbers appeared in rolling of two dice once. Sum of numbers rolling of two dice once. Sum means addition. So minimum number, that is 1, 1, that is 2. Maximum number is 6, 6, that is 12. How we come so check that portion here. Minimum number is 1, 1. If you add it, that is 2, then 3, then 4, like this. At most number is 6, 6, that is 12. So from 2 to 12, all number exist. So you will write in this way. So let A is the event that sum is even in rolling of two dice once. You'll take A because your question is you have to express sum of numbers appeared in rolling of two dice once as mutually exclusive event. That means you have to find out which one is your mutually exclusive event. If I'll write A is the event that the sum is even in rolling of two dice once, and B is the event that the sum is odd in rolling of two dice once. So what will happen? A having element 2, 4, 6 up to 12 because at most point is 12. Similarly, B, T 5, 7, 9, 11. And if you take and if you want to find A intersection B, then what is A intersection B value? Check that A and B, here no common points are there, then it is phi. So if A intersection B is phi, then they are mutually exclusive. Okay, then another example 4.13. Suppose if A and B are hitting a target, then the hitting target by A is not depend on, is no mutually exclusive with hitting target of B, because hitting target of A is different, hitting target of B is different. So A and B are different. If you take intersection, then it is phi, then they are mutually exclusive. Then in another class, I'll explain what is independent event, what is conditional probability, and what is first probability. Okay, thank you. Thank you all.